Hi everyone, my name is Dr. Vile. Welcome to my YouTube channel, which is all about A-level chemistry and how to prepare for your exams. If you find this video helpful, please like and please subscribe to the channel. The purpose of this video is going to be all about standard solutions. So we're going to look at how you make a standard solution and what they are. So a standard solution is all about making a solution that has a very specific concentration. So it might be you work in a lab and you have to make a solution of something like sodium hydroxide that has a concentration of 0.2 moles per dm cubed, and you might have to go away and work out how much solid you would need to add. So that's the kind of calculations we're going to look at. I'm going to focus on the calculations more than how you prepare it practically in the lab, but I might talk about that a little bit as well. As always with all these videos, I'm going to focus them around questions. So the first question says, a lab technician needs to prepare 500 millilitres of 0.2 moles per dm cubed of potassium hydroxide. What mass of the solid is required? So if you have a question like this, where you have a concentration and a volume, the formula that you're going to need is number of moles, which we'll just call N, is equal to the concentration, C, times the volume, V. Now, the concentration is measured in moles per decimeter cubed, as we can see here, but here the volume is given in millilitres. Now there are 1000 millilitres in a decimeter cube, so we need to standardize the units. So the volume needs to be converted to decimeters cubed, so we just divide by 1000. So the formula becomes N equals CV over 1000 when the volume is in millilitres. And now we plug our numbers in. The concentration is 0.2. The volume is 500. And then divide that all by 1000. And that comes out as 0.1 moles. The next piece of information that we're going to need is the formula of potassium hydroxide. So that's KOH. If you're not sure where I got that from, there's another video elsewhere on here about writing formulae for ionic compounds. Potassium is 39.1. Just look that up on your periodic table, the atomic mass. Oxygen is 16. And hydrogen is 1.01. So that comes to 56.11. And then finally, we need to know that let me just put a little box down here so we don't confuse things. We know that the number of moles, N, equals the mass, M, divided by the molecular mass, which is MR. And we know the number of moles, and we know the molecular mass. Therefore, if we rearrange this equation, we can say that M, the mass, is equal to N times MR. So that's 0.1 times 56.11. So the answer is going to come out as 5.61 grams. So what this means is that the lab technician would need to take 5.61 grams of the solid and weigh it out accurately, transfer that into something like a small beaker. They'd dissolve it in, say, 100 mils of water. They'd then transfer that to a volumetric flask, and then they would wash it through with a bit more water, and then they'd make it up to 500 mils. But they'd need 5.61 grams. A student dissolves 0.5 grams of sodium hydroxide in 250 ml of water. Calculate the concentration of the resulting solution. So firstly, let's calculate the moles in the 0.5 grams. So we know that N, number of moles, is equal to M over MR. So that's 0.500 divided by the MR of sodium hydroxide. Now I've skipped a step here. We know that sodium hydroxide is NaOH. So that's 23 plus 16 plus 1.01. So that's 40.01. And that comes out as 0.0125 moles. Now leave that number in the calculator, by the way, whenever you have a multi-step calculation. I've rounded here, but I'm leaving it in my calculator as I go forward. And then we saw on the previous problem that number of moles is equal to concentration times volume divided by 1,000 when the volume is in milliliters. So we're going to rearrange this to make C the subject. So you times both sides by 1,000 to start off with. So you could say N times 1,000 equals CV, and then just divide by V equals C. And now we're in a position where we can plug the numbers in to get our final answer. So the number of moles is from the previous question, 0.0125. Times 1,000 divided by the volume, which is 250. And that'll give us the concentration. And that comes out to three significant figures as 0.0500. And because it's concentration, the units would be moles per dm cubed. Moles dm to the minus 3. Well, I hope that video was helpful in answering some of your questions about preparing standard solutions. If you have found it helpful, remember to like and subscribe. See you next time.